Good morning. Welcome to the size reduction video tutorial. This video will outline materials required and procedure to be followed when conducting a size reduction analysis. First, let's start with some background. Particle size reduction is used to pellet biomass for solid fuel, improve ease in transportation, or increase the specific surface area to improve reactivity. Typically, size reduction is a mechanical process and consists of cutting, chopping, or grinding, usually with machines with working parts and required energy input. Therefore, the measurement of size-reduced biomass is critical. Particle size analysis is used to gather information such as the size range, average size, or mean size of the particles in a sample. This is used to create various weighted averages in biomass processing industries. Distribution of particle sizes can be done in a variety of means, with the most common being to shake the biomass particles through a series of sieves and measure the mass distribution. Assuming a shape and density to the biomass particles, a size distribution can be generated. In this lab, particle size analysis will be done using a similar technique to microscope counting, except instead of a microscope, we will be using a scanner and ImageJ software to analyze different particulate matter. Next, let's move on to the setup of the lab. First, make sure ImageJ software is installed on the computer you wish to use. After that, either obtain image files of scanned biomass particles or gather your biomass you wish to use for the particle analysis. Disperse the particles onto the scanner, making sure they are separated and easy to distinguish between the different particles. Include an object with an already determined diameter, like a quarter. Scan the necessary images into the computer to be used with the ImageJ software. With the proper image files and software on the computer, you should be ready to start your particle analysis. First, open the ImageJ software. Then to open your images with the software, go to File, Open, and find where the images of the desired particles were saved. Next, click and drag so a yellow box outlines the area you wish to analyze. Then go to Edit, Clear Outside. The rest of the image will be removed to avoid clutter. To properly measure the size of the particles, a scale for the image in the program must be set. This is done by zooming in on the quarter by clicking Image, then Zoom. Once the quarter takes up the majority of the screen, select the straight line feature and draw the line from one side of the quarter to the other. Then click Analyze, Set Scale. Keep the distance in pixels the same. This is the length of your drawn line. The known distance of the line should be 24.46 millimeters. Keep the pixel ratio at 1, and the unit length should be millimeters. To test the accuracy of the scale, draw another line across the quarter. It should be close to 24.46 millimeters. Now the threshold range must be set. The ImageJ software requires that the image be a binary image that consists only of two colors, so a range must be set so the particles within the range will be one color, and the particles outside the range will be another, typically black and white. This is done by selecting Image, Adjust, then Threshold. At first, the particles within the threshold will appear red. Adjust the brightness to include the particles you desire. When ready, click Apply. Then go to Process Binary, Make Binary to turn the image into a black and white one. If there are objects in your image that are overlapping a little, they may be separated by selecting Process, Binary, then Watershed. With the image now binary and a scale set, ImageJ is now able to analyze the particles in the image. First, select Analyze, Analyze Particles to gather information on particle size and number of particles. If there are outliers, set the minimum and maximum to the desired amount to avoid tiny specks of dust being analyzed as well. Select the Show Outlines option to display an image of the detected objects with their outline and the corresponding particle number. Further analysis is done by copying the charts displayed after the analysis into an SS program, such as Excel. It is suggested that ferrite diameter in millimeters, area in millimeters squared, and particle number all be copied. To perform analysis in Excel, create bin data to make it similar to sieve analysis. Further analysis of the particles can be done on charts and graphs using the Charts tab in Excel. This is to be followed by particles in the chart displayed in the Averages tab. Thank you for watching this instructional tutorial on size reduction and analysis.